What's up, everyone? Let's get ready for Fun with Derivatives Part 3. So this is the third part of a series of videos we're talking about what you could do after you have a derivative. And we've been exploring four things. In this video, we're going to talk about the final fourth thing that we could do. So it is find the equation of a line tangent to a function that runs through a given point that's not on the function. Okay, the key thing here is that the given point is not on the function. Please remember, a derivative can only find a derivative can only find the slope, the rate of change, at a point on the function. But in this case, the point I'm giving you is not on the function. So how's that going to work? Well, as I've always said in this class, a picture is truly worth 1,000 words. Sometimes reading what you're asked to find is kind of hard, whereas seeing it is a lot easier. So here we have an example of exactly what I'm talking about. So first we have a function, f of x. Here it is. Looks like a beautiful parabola maybe. And notice we have a point right here that is not on the function. Now, of course, that point has an x-coordinate, has a y-coordinate, but notice that if I find the derivative of my function, I cannot plug this x value in because that's not going to do me any good. Remember, the derivative is a formula to find the slope at any point that is on the function. And unfortunately, this blue point is not on the function. But this is where you got to really understand what it is you're asked to find. We want to find a line that is tangent to the function. Okay, check, I got that. But it also runs through this given point. So I need to find a line that connects through this blue point. Millions of lines connect through that blue point. And I want to find the line that specifically connects to that blue point and is tangent to my graph. So for example, I'm thinking about maybe this line right here. That looks pretty nice, right? Looks like it would have a point of tangency somewhere right around here. And it would beautifully be tangent to my function and cross through my blue point. And to be honest, it looks like there maybe, again, this is the whole solving process will tell you, but there's another line that would possibly be tangent up here somewhere and then come through and cross through that blue line as well. And again, could be two answers if you see that there's two possible lines that meet the qualifications asked. But again, you really need to understand what those qualifications are. Got to pass through the given point, not on the function, and be tangent to the given function. So, oh boy, this is going to be a doozy. So here's the idea, right? To find the equation of a line, you need two things. You need the slope, which I don't know. I mean, at least in the previous problems we talked about in part 2, we were given a line that we wanted to be parallel to. And if we're parallel, we have the same slopes. That kind of helped us. But I have no idea what the slope of this line is. And the other thing you need to find the equation of a line is that point of tangency, right? For example, if I'm going to find this line right here, I'll try to darken it in, right? Sorry, it doesn't look too straight. Well, I need to find this point. I need the point of tangency and the slope of that line. I mean, the good news is what I need is x. I need the x-coordinate because if I have the x-coordinate, I could plug it into f of x to get the y. I could plug it into my derivative to get the slope. Awesome, great, fantastic. But how the heck do I find that? Well, it's going to involve some really fun math that you're going to love. And to be honest, the most kids struggle with this. Has nothing to do with derivatives and nothing to do with calculus. It's all about algebra. So hopefully you pay attention and understand. All right, here we go. So here is our first official example of this. Find the equations of the lines. Again, what are those S's for in parentheses? Well, maybe there's more than one answer, as we just saw in that previous picture I drew. So find the equations of the lines that is tangent to the function 4x squared minus 7x plus 2 and passes through the point 1, negative 5 that's not on the function. And that's super important because if you go back to Fun with Derivatives Part 1, when we were saying, hey, find the slope at this point, find the tangent line at this point, the points were on the function. And that's what derivatives are meant to find, slopes for points that are on the function. So it's important that this problem is completely different from that because the point 1, negative 5 is not on the function. And there's two ways you could prove that. One is to plug 1 into the function and you're not going to get negative 5. The second is to take a look at a graph. So here is the graph of the function. I actually graphed it. It's a nice, very pretty parabola. And here is the point down here at the bottom 1 comma negative 5. It almost looks like it's directly underneath the vertex, but it's actually a little bit to the right. It's not directly underneath it. So I'm really lost here because I really don't know a whole lot. But again, it's super important that you understand what it is we're looking for. We're trying to find the equation of the line that crosses through my purple point and is tangent to my function. So I'm thinking somewhere maybe up here. I don't know, this is just a really rough and non-straight line, but somewhere around here, I don't really know, but somewhere around here I can have my point of tangency, and then I see that it connects to this line. And like I said, there might be even another answer, again, somewhere over here, it's hard to say, but they're tangent, and then I come down and cross, okay? So, let's just think about one of these lines, right? Sometimes we get kind of confused, and we try to do too much, right? So if there are two answers, the process I'm about to teach you will unveil those two answers. So let's just kind of think about one answer, right? So let's just put a point right here. I don't know if this is the right point or not, but I'm just doing it so I kind of understand what I'm looking for. So that point is called the point of tangency. That is the point that where my line that I'm looking for is tangent to the function, but also comes down here and crosses through this point. I need to find that point of tangency. And what's really important is that I find the x, because if I find the x, I can plug it into the function to get y. And if I have the x, I can plug it into the derivative, f prime of x, to get the slope. So it's really hinges that I find that x. How can I find that x? Oh, boy. Okay, well, here is how I'm going to do this. The first thing I need to do is I need to find the derivative. I mean, like, come on, right? You need to find the derivative of this function. Obviously, the derivative is going to produce that slope for us, so at some point, I'm going to need that derivative. So let's go ahead and do that right now. And again, this video is not meant to teach you how to find derivatives. You should be able to find derivatives on your own at this point. So here it is. The derivative of this function is 8x minus 7. Pretty easy, just using some power rules there. All right, well, once again, I don't know what this x is. This x right here. Sorry, I just kind of scribbled over. I don't know what that x is. I really want to know what this x is. I don't know what it is. If I know what it is, I can get the slope of my line, right? And the other thing is if I know that x, I can plug it into my original function to get the y. So how the heck do I find, how do I find that? Well, here's the deal. And this is a really cool concept that you really need to kind of process to understand. I know this point down here, this purple point right here, was 1 comma negative 5. And I want to know this point desperately. But think about this, right? There's two ways that we could find the slope of that line. Truly, listen to this. This is awesome. There's two ways to find the slope of that red line. One is to use the derivative. 8x plus 7. Right? That's one way to find the derivative. I take that back. I'm so sorry. Minus 7. Don't want to make a silly mistake like that in the middle of a problem. 8x minus 7. That is one way that if I know x, I can plug it in, and man, oh man, I can get that derivative. I can get that slope. Okay? A second way, now think about this, right? We got to go back to algebra 1. A second way that I could find the slope, right? This is what, the derivative is one way to find slope, m. A second way to find the slope of that red line is just old school algebra 1. Take the y coordinate right here and subtract the y coordinate right here, negative 5. And then in the denominator, take the x coordinate minus the x coordinate of 1. And that produces y plus 5 over x minus 1. So here's the thing. Both of these are formulas that can find the slope of that red line. One is the derivative. You tell me x, I guarantee I can get this. I can get the slope of that red line. Here's another one that can find the slope of that red line. And here's how I'm going to connect these two things together. Both of those are slopes. Both of those are ways that I can find the slope. So why don't I set them equal to each other? The derivative is a way to find slope. But now this formula, y plus 5 divided by x minus 1, is another way, using old school algebra, to find the slope of that line. So if I'm just trying to say, hey, listen, I have no idea what x is, but I have two ways to find the slope of that red line. The derivative, old school algebra. Set those equal to each other, because they're going to be the same, right? And now I have an equation that I can solve for x. The only lingering thing I have to figure out is what is y? Well, come on. Remember, y is your function, right? F of x is just a fancy way of saying y, right? Because if you know x, you just plug it into f of x to get y. So generically speaking, y is 4x squared minus 7x plus 2. Remember, I can't solve an equation if there's two unknowns, x and y, but I could replace that y with 4x squared minus 7x plus 2, because that's what y is, right, in terms of x. Plus 5, all divided by x minus 1. All right, so let me make sure that everybody understands where we're at right now. This is where a picture is really worth 1,000 words. Drew a picture, and I just kind of said, hey, I need to find this point of tangency. I have no idea what it is. I'm just going to label it x comma y. And that point of tangency, if I know that x, I could use the derivative to find the slope. The derivative is 8x minus 7, easy. But if I have 2 points, I could also find the slope by using old school algebra, y minus the y coordinate of negative 5, x minus the x coordinate of 1. And that produced the y plus 5 over x minus 1. Again, another formula to find slope from algebra class. And then I just had to replace that y with f of x, because that's what y is in terms of x. 4x squared minus 7x plus 2. So that's where I'm at right now. And now what I need to do is solve for x. I need to solve for x. And that is the x I'm looking for, right? If I solve for x, that's this x right here. The x at my point of tangency that I so desperately want to find. So let's get right to it. Cross multiply. Treat this as 8x minus 7 over 1. And I get 4x squared minus 7x plus 7. I can go ahead and combine that 2 and that 5 right back here to get that 7. And on the other side, I have to do 8x minus 7 times x minus 1. That's going to involve a little bit of multiplication. No big deal. 8x squared, negative 8x, negative 7x plus 7. And I still got my 4x squared minus 7x plus 7 on the left. And now I'm going to combine all of my like terms. So I got 4x squared minus 7x plus 7 equals 8x squared minus 15x, when I combine the negative 8 and negative 7x, plus 7. Now I clearly have a quadratic, so I'm going to move everything to the right-hand side. So I'm going to subtract 4x squared over, which makes a 4x squared. I'm going to add a 7x over, which makes a negative 8x. Again, I'm adding this 7x over. And then I'm going to subtract 7 over, which makes a 0. So this actually works out to be a fairly easy quadratic. Okay, how do I solve this? Well, I could factor quadratic formula, or I could graph it and see where my graph crosses the x-axis. But I'm going to go ahead and factor this. It's actually a pretty easy one to factor. I could factor out a 4 and an x, and I'm left with x minus 2. Hopefully you guys see that. That's pretty easy, right? And this means that using the zero product property, 4x equals 0. That's the first factor right here. Because if 4x equals 0, then 0 times anything is going to make a 0. Or x minus 2 equals 0. And again, if x minus 2 equals 0, then 0 times anything is 0. So here I get x equals 0 and x equals 2. So these are so there's actually two solutions, right? So this leads me to see that there are two solutions. One happens at a point of tangency where x equals 0, and one happens at a point of tangency of x equals 2. So now I could go back to my graph here, and I could say, all right, when x equals 0, so I was actually a little bit off, right, because I put my red dot up here. But remember, I was just putting that dot because I didn't really know where it was. But when x equals 0, looks like right here, that is going to be a point of tangency where my tangent line crosses through the point 1, negative 5. And the second one is going to be when x equals 2, which is right around here. All right, so now I'm almost done. I just need a couple things, right? So let's just do one at a time. Let's not try to get overzealous here. So if x equals 0, the first thing I have to do is find my y coordinate. How do you find the y coordinate? You got to go all the way back to your original function and plug in 0. So 4 times 0 squared minus 7 times 0 plus 2. That's going to be 0 minus 0 plus 2. So my y coordinate would be 2. And I could actually see that in the graph as well. I mean, it was pretty obvious in the graph at that point was at 0, 2. But I'd like to make sure I know algebra to find it. All right, the next thing I need to know is the slope. And I could then plug 0 into my derivative, which was 8x minus 7. So 8 times 0 minus 7 gives me a slope of negative 7. So my point is 0, 2. My slope is -7. So again, creating that line would be y minus 2 equals -7 times x minus 0. So that is going to be one of my lines that is tangent to my function and crosses through the point 1, -5. That's going to be this line right here. It's tangent at 0, 2, and, sorry, I'm so bad at drawing lines, crosses through 1, -5. All right, let's find the other answer. Now, the other answer happens when x equals 2. So the first thing I got to do is find the matching y coordinate. How do I do that? Got to go all the way back to my original function and plug in 2. So I get 4 times 2 squared minus 7 times 2 plus 2. 2 squared is 4. 4 times 4 is 16. -7 times 2 is -14 plus 2. 16 minus 14 is 2. 2 plus 2 is 4. So again, my point is at 2, 4. That was pretty obvious in the graph as well. If you look at this point right here, here's that point 2, 4. But, you know, sometimes looking at graphs, you may think it looks like where you want it to be, but, you know, doing the algebra confirms it. And I also need my slope for that point. So once again, I'm going to plug 2 into my derivative, 8x minus 7. So 8 times 2 minus 7. That's going to be 16 minus 7. So that has a slope of 9. So that line is going to be y minus 4 equals my slope of 9 times x minus 2. So that's going to be another line that creates exactly what I'm looking for. Tangent to my function, there it is, and sorry for my bad lines, crosses through the point 1, -5. Now the best way to check this is using our friend Desmos. It makes it so awesome. All right, so here is what I did in Desmos. I graphed my function, 4x squared minus 7x plus 2. We see it as a black parabola there. If you don't like that black color, we can always change it to, there you go, blue. And then we also graphed the point, 1, -5. And that point is down here in red. You see it down here at the very bottom. Now what I want to do is graph my two answers to see what they look like and make sure that it actually works the way it's supposed to work. And there they are. I typed them in really quickly. And I didn't want to waste time typing them in. You have to hear you hear me typing. But anyway, I typed them in real quick, and look at this. Perfect, right? First thing we see is that both lines definitely cross to the point 1, -5. I mean, if they don't cross to the point they were supposed to cross through, sorry, you're going to get it wrong. But I also see that they are, excuse me, beautifully tangent. One is tangent right here at 0, 2. Perfectly tangent. There's that purple line, y minus 2 equals -7 times x minus 0. And then we also have this orange line that's perfectly tangent right, where's it at? There it is, 2, 4, and there it is, tangent at 2, 4, comes down and crosses here. And you can even zoom out to really get a nice view of these two lines that are beautifully, perfectly tangent to the function, but also cross to the point 1, -5. So these are really, really, really good algebra problems. I mean, if you think about the calculus portion of this problem, it was really just finding the derivative. Which took all of what? 3 seconds, if you know what you're doing. 8x minus 7. So the really good part of this problem is to understand is first, we know what am I looking for and how can I strategize to find it? And the idea is I'm looking for a line and I don't know a slope. I don't know a point. I really don't know anything. And that's where drawing it really helps. And again, you don't have to even draw it accurately. Like my first attempt at drawing it was that red dot, which clearly wasn't right. But again, I didn't know what the answer was. I just knew it was somewhere over there. And I labeled that point x, y, because that's the point I desperately need to find. And then I said, all right, well, you know, how can I connect this all together? And that's where I came up with the idea of saying, hey, the derivative, 8x minus 7, is a formula to find the slope of that line. But old school algebra is also another way to find the slope of that line. And since the slopes are equal, obviously it's the same line, then those two formulas must be equal, which allowed me to do some, you know, pretty good algebra, but I wouldn't call this difficult at all. That's basic algebra solving. And it produced these two awesome answers, which, you know, led me to realizing, oh, wow, yeah, there really are two answers. And I slowly got them. But again, once you get your x's, you then have to find the corresponding points, x, y, and the corresponding slopes by just plugging x into the derivatives to get those slopes. So what a cool problem. We're going to practice a lot of these as well. But these are really fun problems. These are the upper echelon of problems. And a lot of kids say, oh, these are so difficult. Listen, if you know what you're doing, if you understand how I came up with my solutions, these are not difficult at all. The only place you're going to mess up is if you're really bad at algebra. So hopefully you're not. All right, guys, see you later. Hopefully you understand how to do these problems. We're going to practice a lot more.